For decades, Saudi Arabia and Russia have been world leaders in shale gas and oil extractions. However, in the last few years, a new competitor has risen, willing to change the balance: the United States. This increase in the extractions has made crude prices slump, and the US has almost become independent of hydrocarbon imports for energy generation and has significantly reduced its climate gas footprint. Such an enormous benefit for the American energy business is due to a new technique that has turned into the cornerstone of shale gas industry. We are talking about fracking.
Fracking is an industrial procedure, and any industrial procedure brings risks with it. So the purpose of providing such a best practice recommendations is not only to help the operators in selecting, characterization, and operate the site for the shale gas production, but also to provide input, maybe even important and critical input for the regulations that's being established in the different countries. Eventually, advances in both the operation and regulatory framework and conditions are essential for ensuring the public safety.
Fracking in Europe has created a strong controversy among the population, since some kind of regulation is demanded. But what is fracking, and what are these potential risks? What regulations should be applied?
So fracking, as people call it, is actually technically hydraulic fracturing. It's something that was invented long, long ago. It's been used many, many, many times around the world to basically change the properties of rocks to allow more of the fluids to escape from those rocks. And those fluids that we're interested in would be hydrocarbons. So a horizontal well plus hydraulic fracturing creates a real change in the way things are done. And the strategy now is to drill this long horizontal well, first drilling down vertically, and then the well is drilled out to a long distance. Hydraulic fractures are then installed or created at points along the well to generate a lot of area where new breaks are created in the rock. And those breaks, those cracks, fractures, allow hydrocarbons to flow a short distance from the rock into that fracture and then connect to the well and then be produced out of the well, put into a pipeline, and that's what we're trying to do.
Apart from the horizontal well, which constitutes the main difference between hydraulic fracturing and common shale gas and oil extractions, one of the particular aspects of fracking is actually the use of water to obtain these elements. Water goes in at high pressure in order to break the rocks that contain the gas, so it can get into the well.
As it does that, we often find, most of the time in fact, that crack that we're creating takes advantage of pre-existing fractures and breaks in the rock and networks and becomes a little bit more diffuse, which is good from the standpoint of more flow potential. But that's not completely good.
Due to the concern and the controversy the fracking technique has created among the general public, the European Union issued a call to look at reducing the environmental impact of fracking in Europe. The project is named FracRisk.
The motivation of FracRisk is that fracking as a technique has been great in increasing the amount of hydrocarbon exploitation. Natural gas has become cheap in the US thanks to fracking, but in parallel to that, there has been some negative impacts, especially the flow of contaminants, of toxic contaminants into aquifers.
We want to set up procedures to minimize that impact, and in operations which exist outside of Europe, we already see this happening.
FracRisk is the name of an EU Horizon 2020 research project. It's the name of a consortium of about 13 different partners. About 10 of them are university or academic institutions spread throughout Europe, and about 3 are industrial partners.
We are scientists coming from a variety of disciplines, from geochemistry, geophysics, from hydrogeology, from engineering. So the guidelines are simply for everybody to do the best science he or she can, to connect actually these different communities.
The general mistrust that revolves around fracking has pushed this group of scientists to take action on the matter. But in order to understand this, why such a big part of the population is worried about this issue? What are the terrible disadvantages that have created a public objection like this?
For instance, if you inject water in a reservoir with organic matter, you will have microbes growing. But these microbes would make it difficult for the gas to flow out. So you don't want the microbes to grow, and therefore you add biocides. If the biocides reach the environment, that would be a problem for the people who use this groundwater.
And therefore, that's a pollution mitigation activity that needs to be treated, first of all, at the source by making sure that everything is done for it to not happen. But once it can happen, we need to detect it and we need to mitigate it, because if the pollution is mitigated at the source, then it is much easier than waiting for it to spread into the aquifer. It's much more complex.
FracRisk tries to go further into the depth of all these different processes and finds detailed answers to this general kind of risk assessment of contamination of surface groundwater, drinking water.
The purpose in the FracRisk project on this matter would be to determine and define some scientific aspects so that these contaminant elements don't reach the aquifers.
So we have these 2 different fluids. We have our formation fluids, which are the original depositional fluids, and we have our injection fluids, which are used to frack the formation. And both of these fluids are then produced while the gas is produced with it. And it's the chemical composition of these fluids that might cause concern during the operations. So I undertake experimental work to investigate the components within each of these fluids to see which ones are going to cause any problems in the environment and work out how we can minimize these.
More and more the companies are using chemicals which are sort of environmentally friendly, if you like. In fact, many of the chemicals that they use are used in food production, so they're not necessarily very polluting. Some of the chemicals they use are used in households for cleaning, so they're not chemicals which people aren't already sort of being exposed to in some way. But nonetheless, if you're using them in large volumes and you're putting them into the environment in some way, we need to make sure that's done in a responsible way so that it can't escape into the environment in an uncontrolled manner. And again, it's about providing reassurance to the public that we are managing these processes properly.
It's important to understand that there's a very wide range of regulation, both at the European and national level, to protect the environment. And this means protecting human health and the environment, which includes groundwater, and that's a very important part of that.
We consider modeling as an essential tool, actually, of a decision-making process. So it's one of the most essential tools, because you are analyzing then risk-related scenarios. And this includes looking at the source, that is the shale. We look at the pathway that connects the source to a target at the end.
Our role in this project is to build hydromechanical models, how it's important to understand how the stress field changes and how the fracturing changes as a response to fluid injection. And we also build geochemical models. These fracking fluids, they have chemical additives in them and how those react with the underground environment. So it's important to have a good understanding of those processes so we can make predictions and look at possible risk scenarios.
In FracRisk, we have adopted a platform called REPCA, which is called an acronym for Risk-Based Corrective Action, which is extensively used in the environmental protection of soils and groundwater. Our feeling is that if we use an approach that is commonly accepted in other fields of activity, which are crucial to the economy of any country, then the public could better understand the risks that are involved in fracturing and also how we can manage them.
The second potential type of environmental impact is the escape of natural gas into the air. Natural gas is basically methane, and methane contributes to climate change.
Another risk is due to the very activity of the hydraulic fracturing, which is applying high pressure to a specific layer. The application of that high pressure could induce what is called small earthquakes at the vicinity of the application of the pressure. This is one risk. However, it can be extremely limited if we put very serious constraints of how much pressure can be applied to a specific layer.
One of the ways to mitigate this risk is the adoption of traffic light protocol. It means if you have the green color, you keep on with your injection, then a certain magnitude happens, then it reaches the yellow color, and then when, according to the local jurisdiction that decided the value of stopping of the injection, you can reach also the red color. And this is also a good and best practice way to extract hydrocarbon in a safer way.
At CSIC, the Higher Council for Scientific Research in Spain, we are developing codes, computer codes, to simulate how the rock breaks and what are the magnitude of the microseisms that would be induced by the actual fracking.
So, as we can see, the debate inside the FracRisk project has a very important task. It has to provide the possible measures to establish a regulatory framework in order to diminish the potential risks of this activity.
In everyday life, there's no such thing as a risk-free world. We live with risks, we have to minimize them.
The entire objective of the FracRisk project is really to see that we are not causing any environmentally harmful things with fracking operations. So all of the attempts are actually towards this end, including our model development.
In the UK especially, we have a growing dependence on imported natural gas through liquefied natural gas, where you have to put it on a ship and sail it over. So the role that fracking and shale gas can play is to offset some of that imports that we're depending on. That plays into socioeconomics in a combination of ways. One is, which is very tangible, is the fact that if you produce natural gas indigenously in your own country, then you get the tax revenues, so you can use those tax revenues to reinvest in infrastructure such as renewables. And
initially, I mean, you have some kind of boom situation because of the development of the shale gas. A lot of people get jobs, but the fear is that this ceases after a period of maybe 5, 10, 15 years. And this could have a major impact on the societal structure.
A negative potential, but also a positive potential, and that benefits through the extraction and the sale of the gas to subsidize, to provide a cheaper form of gas, the strategic independence that it brings, producing it within the EU, but also the job generation as well. But there has to be balanced against the potential negative side effects due to health and safety and environmental degradation.
In terms of environmental impacts, the way that we approach and view natural gas is that using natural gas for energy is a displacement against coal. So it has a benefit in the way that it's about half as polluting as using coal would be. It also has a huge benefit that it's readily available to turn on and off, unlike nuclear and coal, which are baselines that play out over long durations.
To a certain point, the research which takes place in FracRisk are not only focused on minimizing the negative environmental risks that this activity may cause, but also to help reduce pollution in other activities that might share a common ground with fracking.
Hydraulic fracturing shares many environmental risks with subsurface processes. Whether you're drilling a well for conventional oil and gas, for geothermal operations, or for hydraulic fracturing itself, you perturb the subsurface in some way.
We feel that the work that we do has quite significant environmental impacts, and we hope that the findings that we have can be used to minimize the environmental risk during any drilling, and in particular drilling for fracturing.
Other countries like Poland have deeply investigated the fracking technique so that they can share their information during the FracRisk project.
We produced 7 environmental reports based on existing wells, proving that actually the fracturing itself is safe, of course provided that you observe all existing regulations and rules. And the experience we gained during the whole operation could be useful for some environmentally friendly technologies like geothermal.
But as they try to find the best possible way to develop fracking in Europe, in the United States it is already a reality. Hydraulic fracturing has shown to work very well in terms of economy in the US. In the east of North America, we find one of the best examples of this technique, the Marcellus Formation.
So the Marcellus is a formation in the Appalachian Basin that consists of shale, and when it was originally deposited about 400 million years ago, the organic material was buried and converted into hydrocarbons. So when energy companies drill into the Marcellus now, they can produce very large volumes of natural gas, which in the United States is estimated to be one of the largest shale gas reservoirs in the world and is currently the most productive shale gas reservoir in the world.
The United States seem to have taken the initiative on this issue, but if there's a chance to see this happening in Europe, we first need a suitable regulation, and that is what FracRisk is about.
Initial project of what I was talking about just lasted for about a year, so it was some kind of initial impetus, but actually the detailed scientific work is being looked into by this group in FracRisk, and so I'm quite happy that it found some continuation.
What we can provide and what we are actually providing are ways which are solid, scientifically based on characterizing the value of the information that we have and ways to collect potential new information and new hard data according to which we can reduce and manage the risk associated with such operations.
Fracking is performed by oil companies, and of course they are interested in doing it as profitable as possible, and people do not trust them. I guess the people would like to have an independent opinion, and scientists are assumed to have an independent opinion.
It's politicians or it's the public which you have to convince that the technology is doable or not.
It can be expected that within the next 10 or 15 years, fracking will be part of a larger mix of energy technologies which are contributing to more significant energy resources at a European level.
Wherever the future of fracking is going, FracRisk project has shown that with a new energy technology, an appropriate regulatory framework is needed in order to obtain and use this resource in the best possible way, minimizing the risks and the environmental impact. Even though there is still much work to do, the quest for knowledge is moving forward every day.